Here is an explanation for the answer to final exam question number 17 in Electronics Demystified, 2nd edition. If you have the printed book, please see the bottom of page 419. We're talking about two different types of rectifier circuits: the full wave bridge rectifier, which uses 4 diodes, and the half wave rectifier, which uses only 1 diode. The full wave bridge rectifier takes advantage of the entire wave cycle. That's where the term full wave comes from. The term bridge comes from the configuration of the 4 diodes in this square or diamond shape. The half wave rectifier circuit only uses half of the AC wave cycle in order to derive the output. Our question is asking us which of the following 4 factors, A, B, C, or D, represents an advantage of the full wave bridge circuit over the half wave circuit, assuming that we use exactly the same transformer in either case. Well, the short answer is E, all of the above. Let's go through them one by one. Choice A: if we connect a significant load to the output of the full wave bridge rectifier circuit, the voltage will drop less than it will with the same load at the output of a half wave circuit. That is true. That's better voltage regulation. This circuit just is more robust. It's just more robust. It has a more massive output for the same voltage. It's capable of delivering more current. So choice A will work. Choice B: the full wave bridge rectifier places less strain on the diodes. Well, that's true, mainly because there are 4 diodes sharing the burden here, but the single diode has to do all of the work here. So choice B also works. Choice C: we can more easily filter the output of the full wave bridge rectifier circuit. That is true, and if you'll go back to question number 14 in this exam, we talked about the full wave rectifier compared with the half wave. The ripple frequency at the output of a full wave bridge is twice what you would get at the output of a half wave circuit. In the United States, for example, where we have 60 Hertz AC input, we'll get a 60 Hertz ripple at this output, but we'll get 120 Hertz ripple at this output, and that's easier to filter because the pulses occur twice as often, so the capacitors only have to discharge for half as long, and that means they don't discharge as much. They can hold the DC better. So choice C works. Choice D: the full wave bridge rectifier places less strain on the transformer. That is true because current flows during the entire AC cycle in the secondary here, but only during half of the cycle here. And when you subject a transformer to an asymmetrical workload like that, it's hard on it. Assuming that you have the same current demand in either case, it's going to be a lot harder on the transformer if you use a half wave rectifier than it will be if you use a full wave bridge. So all 4 of these choices, A, B, C, and D, are valid answers, and that means that the correct answer to this question is E, all of the above.